We've got a short pre-lab here for Lab B. In Lab B, we're going to be looking at freezing and then later also looking at melting. All right. This demonstration is something that you're not going to see. However, in the video of the lab, you will see this activity being done, and hopefully you can do it also on your own at home. It's very simple. Even if you have kids around, you can get them involved with it. That's what I did at my house. So can we take water vapor in air, and water vapor is saying it's water gas, and condense it and then freeze it. So condensing it, we would first turn it into a liquid, and then freeze it, we would turn it into a solid. So we're going to see if we can take the water vapor in air and turn it into a water crystal. Wouldn't have that square shape, but a water crystal as a solid. So you've got the materials that you need to get together here, some directions as well. You're gonna mix, and there's also some additional video animations for you to see what's happening at that particle level. As you do this, then you're going to explain it. So remember, we want to be kind of having this make a claim, have evidence, and then give some reasons to connect that evidence back to the claim. That's kind of the mindset you want to have as you texture your answers. Observations, you practice some of these in Lab A. Think about colors, temperatures, texture, things like that. Be detailed, give good adjectives. Here you're going to be doing more of the reasoning, like why did we see what we saw up here? And again, more reasoning or explaining here, so talking about the molecules. On the next page, you will continue and talk about the speeds of the molecules. So here you don't need to write captions, but we have a couple of pictures to help you think. This is going to be my water in a liquid form, and this is going to be my water in a solid form. And these particles would be moving faster than these particles. You'll see that in the animation. So you want to choose for my liquid water, as they're calling it up above, and the solid ice. You're going to choose some of these descriptors to compare the two. So you want to be thinking about these pictures as you answer those questions up above. Then you will be in the second part of Lab B, where we're going to look at melting. And you will see a piece of ice melt in your lab video when you get to that. Again, thinking about not just what you see, but also the why, what's happening with the molecules. And then you're going to work either with a partner via Zoom or on your own at home using my video, with a kid at home, but work with your people or yourself, your awesome self, to design a way to make ice melt faster. And so you're going to very clearly state your question, and then you're going to give it a try. So you're going to collect here evidence. The more evidence you can give me, the better. And then you're going to explain. Again, we're going to skip writing a caption, but this is my water as a solid. So this is my ice. And then here's my water as a liquid, and that's what they're calling water here. So you're gonna take those and think about our phase changes, okay? You saw some of this with the freezing as well. So just for example, as I go from a solid and I turn into a liquid, that process we call melting, all right? And then you'll fill in what this process is, and this process, and this process here. All right, so you're going to be explaining it with some of these molecule pictures. Next up, you've got more pictures and a couple of things to think about here. So state changes. State changes just means I'm going, say, from solid to liquid to gas. How is that similar between water and other substances? And just one thing I can tell you for all substances, here those particles are not moving very fast at all, and then they start moving faster and even faster. In my solid, my particles are very organized, and then they're less organized, and then they're not organized at all in the gas phase. So those are a couple of things where I would have my particles similar in any substance. One of the biggest strange things about water is you can see that when I go from a liquid to a solid, those particles actually go from being very compact to having some space between them. Can you see the space show up here? And so this is strange in water that your solid is actually less dense or has more air in it than your liquid does. Most substances get more dense. They just pack in and pack in and pack in as they solidify. But water is actually different in that it's packed as a liquid and then it spaces out as a solid. If you drop some solid ice cubes into water, you'll see that the ice cubes float, and that's because water is less dense when it's a solid, when it's frozen. So that's something to think about here. And then finally, we always want to have curious questions, right? So think about regular ice, that's H2O, compared to dry ice, which is carbon dioxide. Do those melt in the same way? You might watch a video of dry ice if you haven't been around any lately. But are those going to be the same, or are they going to be different? And give some observations with that. And also, if you have any other questions, add those on here as well. So that is your freezing and melting experiments.